Hi, in this video we are going to talk about the theoretical background for Sudoku. So let's get started. This is the typical Sudoku. So we have these so-called boxes, that's what we call a single box, and we have three from these single boxes in a single row. We have three of this in a single column. What's the aim of the Sudoku? The aim is to fill a 9x9 chessboard-like grid with digits, as we have discussed. So we have to fill it with digits, and these digits has in a range 1 to 9. So we have to fill it with 1 or 2, 3, 4, 5, 6 up to 9, and we are not able to use zeros. It's very important. So we have some rules, of course. Each columns and each row and each of the 9 3x3 subgrids that compose the grid, that's what we call the boxes, that's what I've been talking about, a single box, contains all of the digits from 1 to 9. So it's very important that we have to make sure that in the solution, in every row we will have all the numbers from 1 to 9, exactly once. All the column will have the numbers from 1 to 9, and all of these boxes will have the numbers from 1 to 9. And of course, in a single box, it is not allowed to have more than, for example, 2 of number 5 or number 6. It is forbidden to have more than 2 number 6 in a single row. So we have to make sure that these are distinct values. So initially we have a partially completed grid, which for a well-posed puzzle has a unique solution, and of course we want to find this solution. So the same integer may not appear twice in the same row, same column, or in any of the 9 3x3 subgrids or boxes. So that's the main rules. So this may be a solution because if you watch closely the solution, every row contains all of the numbers from 1 to 9. And every column contains the numbers from 1 to 9 and exactly once. And all of these subgrids or boxes contains every number in the range of 1 to 9. That's the solution we are looking for. And the problem itself is NP complete. So we are able to solve it for small grids. But suppose that this grid would be, for example, 1000 by 1000 grid. Then we are not able to find any optimal algorithms that can solve this puzzle. Of course, we are able to solve the Sudoku on mobile phones and so on, because it is a very, very small subproblem we try to find. And for small subproblems, we have some algorithms such as even the brute force may work. And we are going to use backtracking, of course. But if we would use it for a huge problem, then we wouldn't be able to write an optimal algorithm that's going to calculate the solution in polynomial time. So of course we are going to use backtracking. So we iterate all the possible solutions for the given Sudoku. If the solutions assigned do not lead to the solution of Sudoku, the algorithm discards the solutions and rollbacks to the original solutions and retries again. So for example, it is the basic we have seen for all the other problems we have been discussing so far. So we try, for example, 1. Is it a feasible solution? And if is it a feasible solution, then we are going to go to the next row. And if you come to the conclusion that it is not a good solution, that we go backtrack. We go back and increment the value in the previous column or previous row. How are we make sure that these answers and these moves will be okay, legal? That we have to check for every insertion. We insert, for example, a number for the row index 2 and column index 4. We have to check that this number is not present in the given row, in the given column, and in the given subgrid or box, as we have been discussing. So these are the three most important facts that we have to consider before we can come to the conclusion that, okay, it is a valid step. We can insert, for example, the number 4 to the row index 0 and column index 3. And then we can insert the 6 for the row index 0 and column index 3 because we start at 0. Okay. So okay, that's what we are going to discuss in the next video, where we are going to implement it from scratch. Thanks for watching.